Hello, everyone. Welcome to Global Hack Week. In this session, we're going to be talking about smart contract vulnerability detection. So if you are coming from the last stream where you learned how to create smart contracts, that's a kind of a great transition of like how to look out for the security of your smart contracts. You'll be learning along with me throughout this stream. I've compiled a few different Python libraries, a few different tools to find the vulnerabilities and kind of enhance the security of your smart contracts. I have found a few different tools we can use kind of in combination to find all those vulnerabilities. But as Web3 is like a relatively like new part of technology, this is also like a pretty new area of security and vulnerability detection. So I'm excited to learn along with y'all and kind of figure out how this process is going to work. So without further ado, I'm going to move over to my code space where we'll be working for the duration of this Global Hack Week stream. If this is your first time joining into Global Hack Week, I'm excited to have you here. My name's Gabriella. I'm a coach here at Major League Hacking, which means I go to different hackathons that are hosted in partnership with Major League Hacking. And I also host different streams like this where I learn along with y'all or sometimes teach you new technologies. Glad to see some familiar faces, or I guess familiar names, or I should say, in the chat. I'm glad to have you all here. But let's get started. So here's a little bit of a background of what we'll be going into today. Initially, what I was interested in doing is like taking existing smart contract data and like trying to use machine learning to like find potential vulnerabilities in smart contracts. But I quickly realized, since this is such a new area of technology, there weren't very many existing data sets of vulnerabilities in smart contracts. So we will be finding those vulnerabilities ourselves, kind of using one of the few data sets and those tools as our guide. But if you're unfamiliar with what a smart contract is, you're kind of new to Web3. I'm like relatively new to Web3 as well. Smart contracts are self-executing contracts with the terms of the contract directly written into the code. They're part of blockchain, which is a Web3 technology, and they're widely used on these different blockchain platforms like Ethereum and other blockchain platforms. We'll be specifically focusing on Ethereum today. We'll be going through Etherscan to find some previous verified contracts and find those codes, which are all publicly available, and scanning through those with the Python libraries. Some pros of smart contracts are they're verifiable, fast, direct, and on the chain. But some cons, as you might have, I guess, gathered from this particular stream, is that they have vulnerabilities that can lead to security breaches and financial losses. And since this is such a new technology, there's a lot of vulnerabilities that haven't been commonly, I guess, like there's no like common quick fixes to these vulnerabilities, unlike some existing financial technology that's been around for a long time. Yes. So some basic, I guess like the only basic definition I have written out in the background document is gas. You will probably see this when we're going through the Etherscan website looking at different verified contracts. But essentially, gas is a fee that is required to conduct a transaction or execute a contract on the Ethereum blockchain platform. Gas is paid in Ethereum or whatever specific blockchain network you're on. Since we're only going to be looking at the Ethereum platform, it's paid in Ethereum, but if it's on a different blockchain platform, that will be, of course, paid in a different blockchain currency. Okay, so going into part one of what we'll be doing today. If you haven't already, make sure you check in with Major League Hacking to get your points and your attendance for today. You can do so with the bit.ly link here. I will share that on screen a little bit larger. I shared it earlier, but make sure that you're signing in so you can get those points. All right, I'll just leave that on screen for a little bit so y'all are able to check in, and we'll kind of continue trekking along. All right, so our goal for today, this is part one of exploring vulnerabilities in smart contracts. We want to utilize Python libraries to find vulnerabilities in smart contracts that are in the Etherscan API. Here is what we'll be going through. I don't know if we're going to get to the API part today, or to be honest, throughout this series, just because it'll take a little bit longer. I'm not sure if we'll have that time, but as you can see here, we have a bunch of verified contracts on the Ethereum network. You can click on this and you're finding the address with like this contract. So we'll be taking these contracts off of the Etherscan website. If we were to make this more advanced, we might use the API later. But as you can see, these are all in Solidity, which is a language that's pretty similar from like what I've seen to Java. This is, I guess, like the closest I've programmed to this language would be Java. I think it's pretty similar to maybe like a less complex C, C++, but pretty long. There is a lot of different, I guess, like different specifications in these contracts. So it'll be interesting to see where those vulnerabilities are coming from. Anyways, the first Python library we'll be using to essentially find these vulnerabilities is Slither, which I found by finding essentially the only, what's it called? Like the only somewhat comprehensive data set of smart contracts with vulnerabilities. So here they are. It's on here. There's Slither, Mithril, Smart Check, Oyant, and Osiris. We might go into some of those other libraries if we have time for it later, but we're going to start off with Slither and go through to kind of match these and see, like, use the existing data sets as kind of our answer key, make sure everything is running properly. But as you can see in the SCRAW ID data set, we're running into, we'll have like the contract address, as well as like the Solidity extension for these different files. And you can see LE, rent, algorithm, DOS, UE. So these are the different vulnerabilities that we're finding in these contracts. And with Scrawl, there was a bunch of different, which specific tool is being used to find that vulnerability. So this is kind of like a more big picture smart contract vulnerability testing. We'll just kind of use this as cross-referencing everything. Yeah, and also if you would like to check out the code that we'll be writing throughout this entire stream, I'll have a bit.ly link that y'all will be able to use towards the end. Let's see if we have any questions so far. Do you use Seahorse, Solana, Python for writing smart contracts? I would love to write some in Python. I haven't personally written any contracts in Python. Whenever I've used Solana, I've used just Rust, but I have only just I've gone through, I don't know if y'all have attended like the intro Solana smart contract stream. I've just kind of gone through like that process, as well as if you attend that stream, there's like a few, I guess, like additional lessons you can follow along. So I've gone through those in the past in Rust, but I haven't done any in Python. So that's actually interesting. I would be interested to go to Seahorse and like try the process in Python. I think I would be better at writing smart contracts in Python because I'm just more familiar with it than Rust. It looks like we have a question about pre-recorded videos or past recorded videos and another hacker answering it. I love to see hackers answering each other's questions. So thank you for that. All right, it looks like we are good on answering questions for now. So let's get back into it. So now that I've found this particular smart contract, this is the first one on here. That I've shown y'all how to look at the code, basically. I'm going to find, let's see, this address, and we're going to go to back here. So we have our verified contracts. You can search for them. So I'm just going to search for this one and see here it is existing. This is in our SCRA ID JSON file. So we're able to see that there is like the LE vulnerability, which I will show you the key to like understand what those different codes mean, because I don't remember what all the different codes mean off the top of my head. We're going to click on this so we can find the smart contract. It looks like it was executed. When was this executed? I'm not seeing it, but I'm just going to bring over this contract source code. And I'm going to bring it into my code space. So I'm going to make a new file, and we're going to just name it test .solidity. Copy this in. And I also, let's see. All right. I think that like with the addresses, we should all be good because none of these are our addresses. Okay, perfect. Okay. And then this will be just kind of our test address for the purposes of this. And then we're going to run through our we're going to run through our Slither tutorial to figure out how to use Slither. Y'all are more than welcome to follow along if you'd like to. I will put this in the chat. So this is essentially referencing everything. This is the bit.ly link to this GitHub repository if you'd like to follow along in real time. So I'll put that in the chat, and then we'll get started with our Slither tutorial. Cool. When I'm sharing the video, I know that sometimes the audio gets a little bit messed up when I'm screen sharing. If y'all are not able to hear the audio, just let me know and I can change the settings to fix that for y'all. I just wanted to make sure that I'm not just like not sharing it with you. All right. I'm going to assume that y'all can also hear the audio along with me. I have the captions turned. You cannot hear the video audio. Let me fiddle with my screen settings. Just one moment. Okay, I see what's going on. So basically, I can share just the tab with the audio. So that's what I'm going to do. And we will go, I guess, back. I'll go back and forth on my own, and then I can kind of update you on what I'm doing in the code. All right, here we go.
How to use it properly, and we will see some live technical examples and demos where Slither can catch and can find vulnerabilities in smart contract. We'll see an example where we give the tool, the automatic tool, a contract and what kind of report it generates, and it basically finds the vulnerability. And we will also see an example where Slither fails to find vulnerability, and we will show why automated tools and Slither, the static analyzer, is not enough when it comes to smart contract security and auditing smart contract, and there is no other than manual smart contract auditing. I will also share some tips and tricks of how to get the most out of Slither. So I hope you're excited, and without further ado, let's get started.
Well, it's time to find a new apartment on Zillow.
Apologize for the ads. That would be a little annoying.
These are all great.
So first, what is Slither? Slither is a tool that automatically can find vulnerabilities in Solidity smart contract. It's called also static analyzer. Why it's called static? Because it's basically statically analyze the smart contract code, and based on different settings and signatures that it has, it detects different patterns of vulnerabilities such as no return value, re-entry attacks, and much more. Slither is a tool that is written in Python, and you will need to install Python on your machine, either if it's Windows, Linux, or Mac, in order to use and run Slither. So the way to think about it is basically Slither is like a snake where you're basically gonna throw on him a smart contract, and he's gonna eat the contract and scan it until he finds all the vulnerabilities that exist in his database. Once it's finished, it's gonna export and generate a short report showing you what kind of vulnerabilities it found on which lines of codes and which functions. Now remember guys, Slither does not come instead of manual smart contract audit by auditing firm, or either if it's auditing contest or a private audit, because Slither sometimes misses vulnerabilities, right? We'll see some examples, live example where we give Slither a smart contract and it's not able, it's going to be failing, it will fail to detect some critical vulnerabilities in smart contracts. So this is the repository of Slither. It's under Critic organization, which is basically an organization under Trail of Bit, which is a very known leading smart contract auditing and security firm. And as you can see here, this is the logo and repository, all the explanation about Slither that I already explained and covered. Here you can see and deep dive into all the different features. You can see some kind of use it, but don't worry, I will show you some examples in a moment. Installation guide using a Docker, Git, or pip, which is package manager for Python, and how to integrate it to your smart contract project. And here you can see a list of all the detectors that Slither is able to detect. Remember, it's limited by the vulnerabilities that it can detect because it's an automated tool that's based on signatures. And this is also called static analysis because it's going to statically scan the code.
Okay, I am just pausing it here to kind of like interject this is why we'll be using Slither in addition to some other vulnerability detection tools, because Slither, like you said, is an automatic tool and is only able to cover like a certain number of smart contract detection or smart contract vulnerabilities, not all of them. This is just like a helpful tool because it's able to have some coverage and make the process go faster. And it looks like y'all are able to hear the audio now, so that's great. Yes. All right.
And find the vulnerabilities based on the signatures that it has on its database. Unlike other tools and other methods like fuzzing and symbolic execution, where we basically try to run and test the smart contracts with different kind of inputs, in Slither, we don't do that. We don't execute a smart contract. We don't send transaction to it. We just scan the code and try to find vulnerabilities automatically. It's called static analysis. And this is a very known term that comes from traditional Web 2 cybersecurity. It's called static analyzers. Another cool page in the GitHub repository is the Slither trophies and the Slither Rect. Slither trophies is basically projects that were saved thanks to the fact that Slither was able to find vulnerabilities in the smart contract. And you can see here a lot of examples where projects weren't hacked because Slither was able to find the vulnerabilities. On the other side, in the Slither Rect section, you can see projects that got hacked in the recent years, like DForce in 2020 or Furu Combo or Force DAO in 2021, that got hacked by very basic common vulnerabilities that could be detected just by running Slither on the smart contracts. And you can see how much value was lost and how much money was stolen from these smart contracts, from $2 million up to $25 million, that in this case was covered, but in other cases, $15 million were just stolen. Now let's get started to installing.
Cool. They have like the list of different, I guess, hacks that were like going on commonly, because like you're able to kind of see like the reason that like smart like contract vulnerability detection is important, because like there are like definite cons to um, smart or there are definite cons to smart contracts. Someone asked, is it like a generative AI in term of vulnerabilities tools? Not necessarily generative AI. That was, I guess, like not generative AI, but like the initial idea I had for this stream was to work on making a model to detect vulnerabilities, but the data isn't quite there yet for smart contracts and like vulnerability detection. It looks like another hacker responded, not AI, just like pattern matching and kind of like finding commonalities and like key pieces of smart contracts that are known vulnerabilities. Yeah, and that like static analysis is not like something new to Web3. It's something that like we use in like more established security practices in Web2. But like we're just applying it like a new way and kind of like hoping to gather like a broader data set of smart contract vulnerabilities. We're able to detect them a little bit faster. All right. So yeah, kind of like a debugger, just like more advanced, and like debugging on like the scale of is this going to like potentially get hacked, and finding out like where there are like I guess there's room for malicious like a malicious intent to kind of like crack your smart contract. And like this hacker pointed out, this is how vulnerability detection is typically run in like Web2 and like the typical security practices of products you use in the day-to-day. Awesome. These are great questions. I love to hear it. All right, let's jump back in. Now that we know a little bit more about smart contracts and Slither, kind of like how it connects to security overall, we'll get into like how to actually use Slither with our smart contracts. Cool.
Later. So the first thing that you need to do, if you don't have already, is download and install Python. Then we will be using works on the process. Now, once you have,
I'm just skipping the Python installation process. We already have that kind of like pre-done in GitHub code spaces. If you're doing it locally, you might need to install Python, but it's pretty easy to follow the documentation.
Python installed, you will have to install Slither. You can simply do so by just running the command pip3 or pip install slither-analyzer.
Okay, so this is something I'm going to be doing in my terminal in code spaces. Pip install Slither analyzer. I'm not able to share my entire window and audio at this exact same time, so I will just walk y'all through like what I completed and like how it worked after the fact if necessary. But that just properly executed. So I have Slither Analyzer installed on my code space.
Pip is Python package manager, and once you will run this command, it will automatically download and install Slither in your computer, in your machine. The first thing that Slither is going to show you is all its help. Now, you don't need all this information. It's a lot of information. You can see here example of how to use the tool. You can give it a target file and some flag parameters that will tell him what kind of scan to do, different options, different parameters, and you can just call the Slither command together with a smart contract or a project directory in order to tell Slither to start scan smart contracts. You can use this help, basically slither-h or slither space --help to see all the different options and flags that you can use in order to narrow down your scan and use more advanced options. Now, here in the success folder, we're going to run Slither on a Foundry project that contains 2 smart contracts that are vulnerable to.
Okay, so like you just said, this has like a lot of like flag commands, which is pretty like standard for Python libraries that are run in the command line. And another cool feature of Solidity Slither is that you're able to run it on the entire directory. So we'll be able to bring over multiple files from this particular Etherscan.
To reentry attacks. By the way, these are 2 exercises from the complete practical smart contract hacking course. And if you want to learn more about smart contract hacking and become one day a smart contract auditor, or just learn how to write the time Slither is able to detect and tell us about those vulnerabilities. So I'm simply gonna run the command slither dot once I'm in the terminal on the selected on the folder with all the found reports. And Slither is running, and as you can see, it basically generated a very nice output for us, divided by 3 colors, okay? So the first color is basically high or critical vulnerabilities that it was able to detect. And as you can see, the first vulnerability that is detected is reentry and etherbank.withdraw ETH. It can also tell us the line of...
All right, so he's going through the particular vulnerabilities in the Solidity files. He was running, since we are taking files from the Etherscan site, I am going to basically skip all the way ahead to when Slither fails to find vulnerabilities. And then I'm also going to change screen so we can run through finding those vulnerabilities on our own in the particular files that we're finding. So I'm going to copy down a few different contracts from that file I was showing y'all earlier. If I'm able to, okay. Let me go back to the contract search. All right, I'm going to change my screen sharing. All right, so here we have this. Here is our Etherscan. All right, so, oh, perfect. Okay, so we are back onto Etherscan. We're seeing that this one has no matching entries. I'm going to go back over here and see if we can find this next contract. I might just start pulling some random ones as well. All contracts, here we go. Bringing in this one. Okay, here's the contract. And to answer the question in the chat that asked, where did I download the Solidity file from on Etherscan? I didn't necessarily download it, but if you can see right here, there's just this copy button where you're able to copy the entirety of the source code to your clipboard, and then I'm pasting it into this code space. These will all be there for y'all to see after the fact. But if you like to do it in real time as well, you can use that function. I'm just going to make a directory of Slither test files. And this is, I made a file, not a folder. Slither test files. All right, here we go. Perfect. Okay, and as you can see here, I installed Slither Analyzer earlier. So I'm just going to clear this and then run Slither just to see what he was showing us earlier with all of these flags. And making sure that there haven't been any updates since the video was made. Okay, so the target can be a solidity file, project directory, contract on a mainnet, or stuff on testnet. Okay, cool. So let's just try slither, and then we're going to do slither test files. Unable to compile all targets. Interesting. I wonder if we do slither slither test files test.sol. Interesting. Okay. Sol C version running. Okay. For some debugging help, I'm going to install Copilot. If y'all have been around in the past, this is essentially just like a GPT chat and integrated into your IDE. I just like find it to be helpful. So we're able to like more quickly understand what errors are. Sandra asked, are we just going to watch a YouTube video on live stream here at Emily's stream? We're going to watch, I guess, like parts of it and then kind of integrate it into our specific project and the different like files we're using. It's just kind of like as a like reference tool rather than something that's like fully written. I find that I absorb the information a little bit better when I'm watching it, and I'm learning along with y'all throughout this process. All right, let's see what Copilot said. So the error message, we are encountering error slither unable to compile all targets. Suggests that slither a solidity, okay, is having trouble compiling the solidity contracts. It could be due to a variety of, okay, so this solidity contracts I took from Etherscan aren't compiling. That's interesting. We might have to go back and look at those a little bit more in detail. This could be due to a variety of reasons, ranging from the syntax errors to missing dependencies, given the limited context that provided code snippet, which is just a closing bracket. Okay. Free of the solidity requires that the contract specifies pragma solidity, a specific version. This might be one of the errors. So I'm going to just search for pragma solidity. We'll see what's happening in here. Okay, that's happening in test.sol. Not this one though. But whenever I ran it on test.sol, it should have been working. Okay, so that is not the issue for this one. Missing or in, okay. Slither configuration. Solidity. Let's see if, I think it might just be the Solidity compiler isn't installed. Yes, I think that was the issue. Okay, let's see. And then I'm going to do solc select which version of solc does slither use. My request was rate limited. Interesting. Am I using Copilot too much? Interesting. Okay. So in that case, I'm going to just Google that. Okay, I might just need to. When I Googled it, it says that using Solci selects makes sense because it automatically selects the version of the Solci that you need to use. It's already here. Okay. Let's try this then. I'm just going to run this on Slither. Okay, the same thing here. Okay, so what I'm seeing online is adding it to the path. This isn't necessarily what is necessarily needed with pip rather than npm. Okay. Okay, I think maybe I just hadn't installed the different versions rather than the library itself. Kind of makes sense. Cool. All right, so let's try running Slither again. Okay. I'm just going to set it equal to the most recent one. Select, use, what on? Oh, okay, I see what's happening. Install. Now let's try. So we'll see select, Slither, test. Okay, here we go. we're finally finding the error in our Solidity file. All right. Okay. Source file. Okay, so we might just need this file installed. So install all right, okay. File outside of allowed directories. Okay, I'm seeing what's going on. So I'm assuming that most of these import statements are taken from a project that was going on locally. That makes sense. Let's see what the import ones are on. It looks like there aren't very many in this, so I'm going to change this to test 2 and see if we're able to test that one. All right. Interesting. All right, so I'm just changing the versioning again. I don't know if it's going to work with Slither or not. Okay. So it looks like it's kind of working. We're just getting a warning rather than errors. So I'm going to just run a Slither. Okay, here we have something. We're actually getting the vulnerabilities. Yay. Okay, so I know I got a little bit quiet into debugging there, just there, as Copilot kind of, I don't know, I guess I had like hit my limit or whatever for the developer, the student developer pack. But anyways, basically I had to install specific Solcy versions and specifically use a Solidity file that did not have import statements from other Solidity files that we do not have access to. I think that I could have maybe avoided that by going through, here's the Solidity file I was talking about. I'm thinking that I guess maybe not if the contract dependencies aren't here. Anyways, we can just like maybe filter for that in the future. But here we have this. So we have this warning that the SPDX license identifier is not provided in the source file. Okay, so we have our detectors. And then I'm going to pull up right here. I guess it's in part 1. The slither documentation, basically. So here are the different detectors. In the tutorial we were going through, we had the different detectors and what it detects, as well as like the impact. We had the different use your publications. I find the examples here, the examples we were talking about. But anyways, back to basically the different detectors. This will provide us some more context on the return statement we're getting here. So info detectors ignores return value by token transfer. Okay, so an unchecked transfer. Three versions of Solidity are used. This specific version constraint is showing multiple issues with, so like right here we have Pragma Solidity at version 0.6.10 is shown to have severe issues. These are the different issues. I'm curious if these match up. I'm just going to choose one at random. Nope. Okay. Here are the known issues with 0.6.10, version constraints. All right. Low-level call and address. Okay. And then all of these. So it looks like there are a lot of deprecated items in the syntax of this test case, which makes sense because this contract was taken, let's see, which particular contract. So it's from 2020. So that makes sense. It's been like 4 years since this smart contract was released. So like the deprecations make sense in the smart contract. And then let's see what other information we're getting. Okay, so parameter. These don't look to be deprecated. These just don't need to be following Solidity naming conventions. That's like also something that could have changed over the past 4 years. I think like that's also like a reason why using programs like this on like kind of like a more automatic basis makes sense both for like Web3 as well as like Web2. Because like if you have like a lot of legacy code, this is like an issue that like you face like with like Web2 stuff now. If it's not updated and you're not replacing deprecated things or like best practices, you could have vulnerabilities and like there can be like major hacks on like important financial data. So yes. Redundant expression. Okay, that's interesting. I'm curious. I'm just going to open this one up kind of randomly to see what this is. Okay, redundant statements. So the severity is like informational. It's like not like that big of a deal. It's just kind of like not best practice. And like the confidence for like whether or not like that's like severe is like pretty like we're like a high confidence that it's like not that big of a deal, but like good to point out. That's why I think it's green as opposed to we have the more severe detectors up here in red. I could be wrong about that though, because I'm again learning with y'all with this. So we have the exploit scenario with this particular redundant statement. Okay, so we have the constructor. Each line references types or identifiers but performs no action with them. So no code will be generated for such statements and they can be removed. So here we have our identifiers. Okay, yeah. So we have basically it's being the uint is being declared both in the constructor as well as like the test, and like not only is it congesting code, but I guess like example of like how that could be exploited is if like you're having either like something that's being like declared 2 times, you're able to kind of alter what that variable is containing in a way that could share financial information or provide like an in for malicious attacks, but isn't necessarily always going to lead to that. Cool. All right, let's see if there's any questions so far. Sharing the repo. Someone is asking, or someone said that Windows 11 Copilot worked better in their opinion. I've never worked with Windows 11 Copilot, so I can't comment. Someone's asking, how do I pull for this particular repository? You're able to do that just by cloning this repository and running git pull, or going through the GUI in your application of the code space. And also, if you just like want to wait until the end of the stream, you can always just like bring down the repository then. All right. Someone brought in something that was in on Solidity or Solc version 0.4. It's running into issues. Okay, that's gonna be a common bug that people run into. Okay, that's interesting. So I'm gonna go back up here and look at this more malicious or more important vulnerability we're detecting. Okay, an unchecked transfer. The severity is high. So if a malicious attacker is able to find an unchecked transfer, the severity could lead to millions of dollars of loss, is what I'm, I guess, like translating the severity to. Medium confidence that, I guess this is high severity. I'm not quite sure. I need to go back and like look at the top of the detector documentation. Okay. Basically, what this vulnerability means is that the return value of an external transfer or just a regular transfer from is not checked. So let's see. Several tokens do not revert in case of failure or return false if one of these tokens is used. And my bank deposit will not revert if the transfer fails. Oh, interesting. An attacker can call deposit for free. So let's look at this particular code. Deposit, okay. Deposit. We have the transfer from the balance. Okay, so in the case, what we need to do is use a safe ERC to ensure, use safe ERC or ensure the transfer fund value is checked. Okay, cool. So I'm curious how we'd integrate that in our contract because we're doing that. Reclaim token. Let's see. Okay, so on this line, we're getting reclaim token ERC20, send all the ETH balance in a contract to another address. We have a reclaim ether function. External only owner. Okay. So I'm thinking, okay, similarly, we need to have a return false statement or be utilizing safe ERC20 rather than IERC20 in this particular instance. Okay. Cool. The more you know. I think like that looks to be like the only like high vulnerability like high vulnerability issue in this Solidity file. So that's interesting. And we can mark that down as, let's see, an unchecked transfer. And let's see, kind of in comparison to this. Oh yeah, we have smart check on this. Let's see, Ellie. I'm going back to this. Test2.solidity severe vulnerability solution is equal to safe ERC 20, I believe. Yes. And then here, I'm going to quickly just go back to ScryID. Cool. So in ScryID, like I said earlier, they have like short, like the explanations of different bugs or different vulnerabilities in the database. So we have in data, where's the documentation? I was reading it before. Here we go. Okay. Vulnerabilities.json contains, okay. Here we go. LE is a locked ether. Okay. So this is the unchecked transfer, not something that we're seeing, I think. Transfer. No, in this list of vulnerabilities that is in ether. But I'm curious. If it's being detected in here. Oh, I see. Because it's... So the error is locked ether because we're not using safe ERC. Interesting. Cool. The more you know. Okay. So I'm going to go back to this, and I'm just going to bring over a few more contracts to test with Slither into Etherscan. I don't think this is the right search bar. So we're going to go to smart contract search under developers. And this is where we're finding, this is where I'm finding the source code. I have a link to this in the GitHub repository, but basically it's under just like the contract. I'm going to be bringing this in. It looks like it's Solidity 0.6. There are a lot of imports. Let's see. Okay. There are 154 files in this contract, so we're not going to be going through that. I'm just going to kind of move on to the next one, where you can find a little bit more simpler contracts. Here we go. This one has 3. It's in the Vote token tracker. Okay, and it just looks like it's one Solidity file. So I think this is a better one to run tests on. So inside of the Slither test files, new file, test 3. And we're getting, okay. Pragma solidity is not 0.6. We'll test that one out anyway. Go terminal. Here we go. Okay. Slither. All right. Oh, okay. It looks like they're using a different version. So let's try solc select install solc select use. Here we go. Okay, so now we're getting some reference. Okay, so now this is a good one because we're seeing some like medium level threats, not just like the no threats versus the intense threats. So yeah, all right. Let's go through and see what different vulnerabilities we have in this particular code. Okay, so we are getting the, okay, array length assignment. Okay, so detects the direct assignment of an array's length. So essentially, because the array is set to a specific length, a malicious actor could set the array length to this like ridiculously long array length, and then one by one, a malicious attacker could enter information that like doesn't need to be in the user index, adding in additional users who like might have like unwanted or unneeded access to whatever particular file. Okay. And I guess like their recommendation is to just like add values as needed, so that like it just like you're basically not able to add in additional users. But I think that's definitely like a very high risk thing, and we're seeing that twice in the user controlled proper proposal function. Cool. Okay. Cool. Okay. We're seeing where the arguments count. Okay. Cool. In this, I'm slightly unfamiliar with the syntax, but it's like kind of making sense. Or at least like getting there kind of conceptually. Cool. Okay. And then the second one is another similar vulnerability we're finding earlier. It's that unchecked transfer we're getting from, let's see which one in particular. We're getting an unchecked transfer from our rescue token. We're ignoring the return value by the transfer, which is causing an unchecked transfer because it's ignoring the return value. Like we talked about earlier, basically, we can call this again and like the token transfer could occur again to a malicious actor or just like multiple times, which is not something we want. So both of these are like pretty high like vulnerability issues. I'm going to, I guess, mention this down here. So we have test 3.sol. We have our severe vulnerabilities. Is an unchecked transfer, as well as our array length assignment, which I think is also pretty important. And then we have our medium vulnerabilities. Okay, so we have a lot of medium length. So the first issue is detector documentation. We're dividing before multiplying. I'm curious to see this. Medium severity, solidities, integer division truncates. So, okay, so we're leading to like a less precise contract, which is important, especially if you're dealing with like a lot of Ethereum. This could like add up to be a very costly mistake over time. So if n is greater than 1 supply, coins will be 0. And then coins would have been 1. So like rather than a integer or something that's like a little bit smaller versus larger, want to just like be more precise overall, so the contract's executing the way it was envisioned. So we just gonna need to switch this. Okay. Division before multiplication. Let's see what else. We have our dangerous strict equalities. Let's see what's going on here. Incorrect equality, medium severity, and the description is we are using strict equalities that can be easily manipulated by an attacker. Okay. Ooh, interesting. So for the return statement, because we're updating the balance with a double equal sign, it could be manipulated by malicious forces. And the recommendation is to not use strict equality if an account has enough Ether or tokens. And the explanation, it relies on fund reach to know when to stop the sale of tokens. Crowd sale reaches 100 Ether. Bob sends 0.1 Ether as a result. Oh, this is because it's a strict equality. It's going to make like an infinite for loop, which is interesting. Cool. So dangerous strict equalities is basically just equal to strict equalities can lead to infinite loop and potentially infinite loss. Cool. All right. So let's move on. After strict equalities, it looks like we have a few other medium level security threats. So we have contracts that lock Ether. This is also a medium. A contract that has a payable function but without a withdrawal capacity. The exploit scenario, we have a locked contract and a function called receive to the payable public. Interesting. So every Ether sent to locked will be lost because there's no withdrawal function, because there's only the one function to receive that payment rather than withdrawing it, and because it's locked with the one function. So I guess like the lesson there is to not create locked contracts that don't have all of the capabilities you need. Interesting. Cool. Okay, so contracts that lock Ether, don't create locked contracts without thinking it through like an engineer. Basically asking questions on all of the possible needed functions / methods. Cool. Okay. So now we're on to re-entrancy. Okay. And this is in multiple places. 3 places, 4 places, 5 places. All right, let's see what it says about reentry. Okay, reentry, no ETH is the check. And we are detecting a reentry bug. Do not report reentries that involve Ether. Let's see. State variable is changed after contract uses call variable. Attacker uses a fallback function, which is automatically executed after Ether is transferred from targeted contract to execute vulnerable function again before the state variable is changed. Oh, interesting. So the reentrancy is basically that it's not updating before an attacker is able to re-enter the contract, and then they're able to send money to themselves they do not have, which can lead both themselves and like the people getting attacked in the hole or just like losing lots of money. So avoiding using call.value. Interesting. And then re-entrancy on multiple fronts can lead to infinite money loss, which all right. And then we have a few other kind of like basic vulnerabilities. Cool. I am going to call for like a brief little intermission to grab some water so I don't lose my voice. And then we can jump back into looking at a few more contracts and then finishing up that tutorial video we were watching earlier to see instances where Solidity is not, or not Solidity, where Slither is not finding vulnerabilities. So I will be back in 2 minutes to finish this up with y'all. So grab some water, head to the restroom, stretch a little bit, but I will be back in a few. All right, and we're back. Okay, the next thing we're going to dive into is looking into how Slither could potentially not detect different smart contract vulnerabilities before I do a little bit of a wrap up. All right, so I do need to change my screen sharing though, so y'all are able to hear. We're sharing the audio. Let me know if you're having any audio issues, and then I will fix that. But I think it should be, working.
Being hacked. But now I want to show you another example that's going to show you why Slither is not enough. And we will see how Slither misses a critical vulnerability in smart contract. And here you can see that I changed already to the failover folder. And this is basically the code that we're going to examine through Slither. This is another exercise, a bit more advanced, that basically includes some replay attacks and some more of a logical exploitation of the smart contracts. We don't exploit like common vulnerability like RNRC, but something a bit more advanced, a bit more logical vulnerability. And this time we'll try to run Slither on this smart contract, redhawks.vip.sol, and let's see if it's able to detect the vulnerability. So Slither will just execute Slither on all the contracts in this folder. Now it found some low severity and medium severity, but we don't see any high severity vulnerability, and it's definitely gonna miss the vulnerability that this smart contract has. It's a very interesting vulnerability, a logical vulnerability that I'm not gonna get into now because it's just gonna spoiler you, and I really want you to give it a try and solve it yourself. And you can do so by signing up to the Smart Contract Hacking course, and you will have this exercise and plenty of other exercises that will take your knowledge and skills in smart contract security to the next level. So I'm very excited for you to just try it yourself and try to find this logical vulnerability that Slither, this automated tool, try to find this logical.
Okay, so we are going to look through this to find the logical vulnerability. Okay. So we have our constants are being declared. The variables are being declared. Okay.
So I'm very excited for you to just try it yourself and try to find this logical vulnerability that Slither, this automated tool, just missed. So
I think what it's failing to find is that it's already setting the max supply, which I think will be yeah, I think it's like it's already setting the max amount to a defined variable. And like we talked about earlier, that can lead to some issues when like you set like the max versus adding in each individual item by itself. It can lead to some issues where malicious attackers are able to essentially add in extra information into that array, into that item, because you're essentially just like leaving open gaps, like where you're able to trade off that information or those like open spots for malicious information that's like allowing for multiple transfers to happen, or for transfers to happen before the like first one executed, things like that. So I think that is what we're seeing there. I'm going to change my screen sharing one more time to go back to our overall tab. All right. Changing the screen one last time. Back over to this. All right. So here we go into our part one wrap up. So we went through Slither, which is a Python library, to find a few basic vulnerabilities in smart contracts that we found in the Etherscan developer API. We weren't making any API calls, but we were just bringing that code over to understand what was going on. And I talked through the vulnerabilities we're getting, potential solutions, and also what things like you might want to be thinking about, both when you're writing smart contracts, but just kind of like web development in general. A lot of these concepts can be applied to Web 2 processes and like Web 2 applications. And just like how you can like engineer that so you're not running into these vulnerabilities to begin with. But kind of like someone had said earlier, these kind of work like a code linting tool, but for finding like common programming mistakes that can lead to security vulnerabilities. Of course, like it's good to like run these so you can find security vulnerabilities after you code them. But I think that like this practice of going through existing smart contracts and finding vulnerabilities that are common among smart contracts. If you remember when we went through this JSON file, there are like so many smart contracts with vulnerabilities, and it shows you like where specifically it's finding them and like what types of vulnerabilities. And in this specific data set, we're seeing like a certain common vulnerabilities that like we want to look out for. And while you can't always avoid them, I think that knowing kind of like the logic behind them and like what those attacks lead to is really important for like software development and like whether it be like Web 2 or Web 3, to kind of like think about that and engineer ahead of time so that you're not running into like a ton of these issues, maybe just one at the end that you need to fix. Whereas if you had thought about it ahead of time and like run through these tests with other smart contracts or other applications, you're able to kind of like think about it a little bit more seriously and think through the entire process ahead of software development or during the software development process, which will save you a lot of time and potentially a lot of headache and money from your application getting hacked. Okay. So we have another comment. It seems like all these smart contracts being based on or using one another, we end up with a very complex dependency chain, possibly with vulnerabilities all over the place. I completely agree. I thought that was like one of like the more interesting things of looking into the smart contracts. Like we initially saw like one of the Solidity files had like 150 files in the contract. And I was like, we're not going through all of that one because downloading and transferring all that over into the code space would take a long time. But also because it's going to take a long time to go through all those vulnerabilities. Even if it's like all just like low level vulnerabilities, there's going to be a lot more. And I think like this is pretty common and like a similar concept to Web 2, because if there's a lot of vulnerabilities that you're not familiar with because you're using like very complex dependencies or libraries and you don't fully understand everything that's going on, it can be very difficult to even think through those potential vulnerabilities and what would be going on to make your code break in the first place, when like you're like there's very valuable time to kind of fix those problems. So having it be less dependent and fully understanding everything that you're using, fully understanding if you want to use dependencies, fully understanding the ones like you implemented, I think is important for security purposes and making sure that your application is as free from vulnerabilities as possible. Of course, having none is going to be very unrealistic for the most part, but thinking about all this, I think, is important, especially with the new world of Web3 and like the financial consequences that can come from financial, like decentralized apps that don't have security. There aren't, I guess, like the typical ways of recouping those funds like there are like what we see on Web 2. So it's, I think, even more important to have strong security in Web 3. All right. I think for the questions, that is it. We were going to continue going through this write-up. We have these different write-ups we had here. I'm going to talk a little bit, I guess I could do a little bit of a write-up of what we did throughout this. We know where to go to for part 2. Installed and debugged Slither. Changed solc select versions to match the Solidity files taken off of the Ether scan. Dev search tool. We also found that the older and more dependency-based apps led to more low or sometimes medium to high vulnerabilities. All right, and then examples of vulnerabilities we detected are here. So I'm going to push all of these changes we made. We didn't necessarily code anything out, but there are these Solidity files, and I will write out as well, like the specific commands that I ran to get this information. So I'm forgetting the command for, am I still out of requests? How to comment code into MD file. Here we go. Back to requests again. All right, so it's just this, I think. And then we'll have just basically, honestly, to run slither name of Solidity file, and then we'll have to debug version issues, usually, because I don't want one of you to get stuck with version issues that we didn't have and not be able to solve it with this. Okay, then you'll just do solc select install version that is equal to Pragma Solidity in sol file, then run solc select use same version you just installed that is in sol file. All right, I think that's all for the commands. I think that's a pretty solid write-up. I'll be pushing this to the GitHub repository, so you're able to go walk through everything we did. I'd recommend just using code spaces so you're not running into any path issues on your local machine. And Python, it should be pre-installed. And GitHub code spaces, if you have the student developer pack, then you can access code spaces for free. You get a limited number of hours in code spaces per month, but I've never hit it, and I'm on code spaces pretty often, so I wouldn't worry about that. But hopefully this got you thinking about security issues with smart contracts. If you just came from the smart contract stream, I hope this kind of added some more context to that. And if you'd like to join in for part 2 of this, we'll be going through a few different versions. We're going through some other Python's vulnerability detection tools. in part 2 and talking more about just like thinking about like Web 3 vulnerability detection, kind of in general and security. You can join me for that. It's not tomorrow, but the next day on Global Hack Week, day 6, I believe, and it will be at it's going to be at 1 p.m. Eastern on day 6. You'll be able to find that more information on the Global Hack Week schedule. And just as a reminder, make sure that you check in for your attendance here at Global Hack Week so you're able to get your attendance points and win any additional swag if you're aiming to do that. I hope you had fun and learned something today during this part 1. And I'm looking forward to seeing you during part 2. Happy hacking, everyone. Thanks for tuning in.